Doors don't belong in the sky, and creative AI knows this. I'm Tonya Hall, and joining me is Dr. David Cox, IBM Director of the MIT-IBM Watson AI Lab of IBM Research. Welcome, David.
Thanks. It's great to be here.
What is the mission of the MIT-IBM Watson AI Lab, and why do you confess to being a recovering academic?
Right. So I've been working for IBM Research for about 2 years now, and I was hired to be the inaugural director of the MIT-IBM Watson AI Lab. Before that, I was a professor at Harvard for 10 years. So this is kind of like my first real job. My mom's very proud of me that I finally got out of school and got a job. Uh, and I left academia. I was very comfortable and very happy in academia, working as a researcher in AI and also in neuroscience. But I left to lead this lab because I'm really passionate about the mission of this lab, which is to bring together academia and industry together in a unique way to really advance the frontiers of AI. Now, everybody's excited about AI, and everyone knows that AI is going to transform how we do everything. But today, actually, a lot of AI is actually hard to use to solve the kinds of problems that we are interested in solving, either in our businesses or hard problems that the world faces. So the mission of the MIT IBM AI Lab is really to enable broad AI. How do we make AI, invent AI, extend AI so that we can use it to solve all of the problems we face every day, not just the ones that are amenable to today's AI?
You spoke at the recent MIT Technology Review Leadership Summit on the topic of empowering human creativity with artificial intelligence. Explain the three steps evolution of AI.
Yeah. So, I think one of the things that's tricky about the term artificial intelligence is we're all using that term, and as a recovering academic, you know, I would say 2018 and before, academics, we were very uncomfortable using the term artificial intelligence. We would try and say machine learning, or we'd be more specific and say something like deep learning. Now, for whatever reason, 2018 and beyond, we've all given up and we're all calling it AI, and that's fine. These are just words. But when I got to IBM Research, they had done something which I really appreciate, which is to frame just some simple adjectives in front of AI to talk about what different kinds of AI we're talking at different moments. So to distinguish what we have today as narrow AI. So narrow AI, it's not to say it's not powerful, but it's fundamentally limited in important ways. So today's AI is really great if you have a well-defined task and you have lots and lots of training data with lots and lots of labels. You can build a system that can, in some cases, perform better than human accuracy or better than human speed. But it can really just do that one thing. And then, on the other side of the spectrum, there's this notion of general AI. And that's something that the press and the public likes to talk about. Think about how is AI, what if AI becomes conscious, and is AI going to replace us, and things like that. Interesting and important discussions for us to be having. But the fact of the matter is, we're not really at the stage yet where there's really any threat of robots taking over the world or AI becoming conscious. But it's really, when we frame those two bookends of narrow AI, what we have today is one thing, and general AI, the sort of broader vision of where AI might go, the real opportunity, we believe, is in between. And that's this notion that I alluded to earlier of broad AI. So how do we make AI that's broadly applicable, that helps us with all the kind of day-to-day problems that we would like to automate? And that's really, that's really the mission of our lab. And I think that's where the real stakes are today for AI. How do we make sure that AI is fair and unbiased? How do we make sure that AI works on all the different kinds of data that we would want it to work on? How do we make sure that AI can work on small data, not just big data? Everyone talks about big data, but there are many cases where we don't have that level of data, or even if we do, we don't have the carefully curated labels that you need to use today's AI methods. And also, how do you make AI more power efficient? How do you make it run on our mobile devices, not just in giant servers? These are kind of the battlegrounds for us to push forward. And maybe slightly counterintuitive dimension of that broad AI is, how do we make AI that's creative, that can actually not just make predictions or help us make decisions, but that can actually empower us to create things? And this is a big new theme, I think, in AI, and one of the things that we're very interested in the lab that I run.
So on that note, then, define creativity in the context of AI, and how does broad AI enable human-like creativity?
Yeah. So when we think about AI and data science and big data today, usually it's about how do we take in data, and then either make a prediction, like we're going to forecast the stock market, or we're going to predict, if supply chains. I think we're seeing right now, the importance of supply chains and how they're interacting in this new post-COVID world. Um, but there's another process of human intelligence that we do where we don't just take in data and make a decision or make a single prediction, but rather we actually create a whole new input. So you can think of creativity, obviously in areas, like art. We don't just take in data and make a decision. We actually create things. We generate things. We paint. We compose music. We write. We produce text. In some areas, this creativity, it seems like the domain of the sole domain of artists. But when we actually take a step back, I would argue that much of our day-to-day job, the jobs we have, are actually creative endeavors. So we make arguments, to support our position. That's a creative endeavor. We're composing data into a persuasive argument that can convince somebody to do something, or designing a product, the humble, lamp, or the desk that I'm using right now. That was a creative effort of an individual to design that and create that. The built environment around us is full of creativity, and even things as boring as concrete and the food we eat. Those are actually the product of huge amounts of human creativity and human effort. And as we look at broadening the aperture of what AI can do, what we're asking is, can we have AI be a co-pilot? Can we have an AI system that doesn't replace us in that creativity? We still want to, as humans, be involved in creating things, but can we have AI be a tool that lets us, build things that we would struggle to build on our own, whether it be formulating new formulations of concrete so that they're more, greenhouse gas efficient, or if we're designing, a building, or even if we're creating art, can we build AI tools that help us do that?
Tell us about GAN Paint and how people can experience AI creativity for themselves.
Right. So we had a project recently that we called GAN Paint that came out of the lab, a collaboration between Hendrik Strobelt and IBM Research Cambridge and Antonio Torralba's lab at MIT. And it was actually a wonderful, happy accident, because the team didn't set out to build a creative tool, but they built one anyway. And this is basically how it happened. So there's a particular kind of AI deep neural network called a generative adversarial network, or GAN. And there's a lot of excitement around these today. And what they do is, rather than taking lots of data in and then producing a prediction or a decision, you can put in a random set of numbers, and they'll turn that random set of numbers into a picture. And in many cases now, we can build these models and train them so they can generate even highly photorealistic pictures, kind of out of thin air. So these are kind of like the imaginary, sort of figments of the imagination of an AI system. And they've gotten very, very good. There's a system called Big GAN, which can produce pictures that are effectively photorealistic. Now, when the team set out to try and understand how these work, one of the interesting things about AI today is oftentimes we can have models that we build ourselves, but we don't always know how they work. Even though we ourselves built them, it's not always the case that we fully understand why they work or how they work. So what this team was doing was looking at these amazing generative adversarial networks and asking, well, how do they work? What does this network know about the real world? You can generate a beautiful picture of a building, but does it know what a window is? Does it know what a tree is? Does it know what a wall is? Or how is it that it can generate these beautiful photorealistic outputs? So what they did is they went through the network and they found a way to sort of interrogate the network, almost as if, imagine the way a neuroscientist might study a brain and figure out what individual neurons do. You can go in, you can look at the activity in the brain and figure out what it's doing and figure out what's going on. They wanted to go in and look in the neural network, take it apart, and then try and understand, is there a neuron that corresponds to trees or to windows or to a door? Are those concepts, those semantic concepts that we take for granted, is that something that this GAN network knows about implicitly? And interestingly, they found that indeed there seem to be neurons, these units in these deep neural networks that correspond to these high-level concepts. And then that's when a happy coincidence happened, where the team realized that, well, if you can find neurons in this network that have, that sort of correspond to these different concepts, that sort of know how to create or generate a door or a wall or a cloud or a tree, well, then why don't we just paint with those? So if we can just turn those off or turn those on, you can basically, sort of induce the GAN to put a tree wherever you want it to put a tree, or put a door wherever you want it to put a door. And it's a new, interesting kind of creativity where rather than having to paint in pixels, now we have a tool where you can paint with ideas, with concepts. And a number of really interesting things happen when they built this tool. And this is a tool that you can go online and use yourself. You can go to ganpaint.io. And what it lets you do is you can paint, you select a concept that you want to draw with, say a tree, then you paint where you want the tree to be, and it'll render a tree. If you paint with the door, if you put it on a wall, it'll actually render that door in the correct orientation for the wall that you're drawing it on. And then interestingly, if you try and paint a tree in the sky, it won't let you do it because it knows the tree shouldn't be in, a door shouldn't be in the sky. So there's a really interesting, different take on how you can create. So people who maybe don't have the artistic skill required to sort of render a tree at the level of pixels or with paint, now are empowered to unleash their creativity in a completely different way that's fundamentally enabled by AI.
Very interesting. Dr. David Cox, IBM Director of the MIT-IBM Watson AI Lab of IBM Research. You talked about how somebody could access that, but if somebody wants to connect with you personally, or maybe they want to find out more about this work, how can they do that?
Great. Well, so the first place you can go to is our website, which is mitibm.mit.edu. And you can also follow me on Twitter. I'm at Neurobongo. Thanks.
Sounds good. Thanks again for joining us, David. And find more of my interviews right here, or go to tonyahall.net. Thanks for watching.